Yeah, good evening, everyone. Let's start off.
Good evening, sir.
This was the last thing that we did. We just introduced differentiation of a vector. Great. Did everyone started giving the exam? If you find any issue or something, let me know. First time, right? You might have any confusion or something. You'll get used to it. Yeah, just make sure to give it at least one day before. Don't give exactly last, maybe 11 o'clock is the deadline when you start writing at 10:30. And nothing can be done in the last moment. Chalo, others, cams on. Let's go ahead. Some people are missing. Great. I hope everyone has tried that assignment sheets, right? So if you have done that, then your differentiation will be like, it's important you do them because you should know how to differentiate at least this much. So let's see some applications of it. Exam interval, good. So if R bar is your position vector, which you have done in vectors, so velocity vector V bar is nothing but dr by dt. So if you differentiate position, you will get velocity vector. Acceleration is nothing but change in velocity by time. So if you differentiate velocity, dv by dt, you get acceleration vector. Now this acceleration can be also written as dv by dt if you multiply and divide by dr by dr. So this term dr by dt becomes velocity. So this term becomes velocity into dv by dr. So acceleration, right, has two formulas. So you can write acceleration as dv by dt. So use this if v is given in terms of time. If someone gives you v in terms of time and they ask you acceleration, use dv by dt. Use this if v is given in terms of position. There. So we are from calculus, we are trying to attack kinematics now. Acceleration, velocity, and everything. The other two formulas, you can note it down in case you don't know. So A can be written as dv by dt or A can be written as v dv by dr. Both are same. Clear with this?
So we have to multiply the v vector or the magnitude of v.
So we will see that in vector. For now, just keep it as magnitude. The actual formula, when we write, we will see this in kinematics. I'll teach you. This is v dv x by xi cap. It's a big one. For now, let's just take it in one direction.
Okay, sir. So it will be multiplied for
that
each
is,
component.
Yeah, एक एक component के लिए करना पड़ेगा. Meaning it will be like vx dvx by dx. This will be I cap. Then vy dvy by dy j cap. So it will be like that. Let's not complicate it right now. We will see that in kinematics. That's a I cap j cap ka thing. For now, let's write as v dv by dr. Don't worry too much about it. Clear with this? Let's see a few questions on this. So for now, we will just do only on one dimension, at least for a few questions. So let's say, let's start with something easy, which we have done last time. Let's see, we will do it again. T square by 2 minus 3t square minus 3t minus 2t plus 1. Find distance traveled in 4 seconds. This is a simpler one. Last time we did the cubic equation. Let's get this. This is an easy one. People are missing today. Let me just take some attendance. Distance traveled in 4 seconds. Why are you giving 4t minus 8? Zero. 8. Okay, we have 2, we have 0, we have 8. 0 तो नहीं है, chance ही नहीं है. Let's see. So in these kind of questions, what are the first step? Find the velocity. Dx by dt. This will be t minus 2. So if you put v is equal to 0, so we'll get a t is equal to 2 seconds, velocity is 0. So meaning t is equal to 2 seconds is the turning point. Meaning this is the time when the particle turns back. Then what to do? You have to draw the distances. So at t0, where are you? At t0, you are at x is equal to 1. Then at t is equal to 2, where are you? At t is equal to 2, that will be 2 square by 2. That is 2 minus 4 plus 1. You're at minus 1. So actually this person is going backward. At t is equal to 2 seconds, this person is at x is equal to minus 1. And then he took a turn. And t is equal to 4, where are you? T is equal to 4, that is 4 square by 2, 8 minus 8 plus 1.
Sir,
Yeah.
at t is equal to 0, wouldn't it be?
T is equal to 0, x is equal to 1, right? God. Just substitute in x, na?
I was substituting in
Yeah.
the loss.
We get x is equal to 1. Is this clear, everyone? Actually, you came back to the same position, basically. At t is equal to 4, you came back to x is equal to 1. Now, if I ask you displacement, what is displacement? You started at 1, you came back to 1. Displacement is 0. But what is the distance traveled? You traveled from 1 to minus 1, that is 2 meters. Then you traveled from minus 1 to plus 1, 2 meters. So what is the distance? 4 meters. Clear with that? If they ask you displacement, then it is 0. So be careful. When I say distance, it's a trap. You have to be careful. Isn't this how we solve this kind of questions? Easy. Got this? Let's see one more. हाँ हो गया. Got something?
Sir,
Advai, बोलो ना.
Sir, how did you find out that the distance traveled is 2 meter exactly? Sorry, that is from T0 to T
Come again, come again.
from T0 to T2. How is the distance traveled 2 meter?
You are going from 1 to -1, right?
Oh,
No?
yes, sir. Yes, sir.
Next one. Let's say x is equal to some constant k into 1 minus e power minus bt. K and b are constants. This is a good one. Can you find initial velocity and acceleration at time t? E is that exponential thing. Hope you remember e power x ka differential is e power x. Let's see. Differentiate this. So velocity will be dx by dt. K is a constant, it comes out. Then you're differentiating 1. Then you're differentiating e power minus bt. 1 is a constant, so this is 0. This is e power a function, isn't it? Chain rule. That is e power something. What is e power something a differential? So this will be k into 0 minus e power something is e power that some function. Then differentiate whatever is that function, which is minus bt. B is again a constant, so it comes out. So that will be k into b e power minus bt dt by dt. Dt by dt is 1, so that will be kb e power minus bt. Have a look at this. Just have a look at this. I'll be back in a minute. Yeah. So once you got the velocity, differentiate it again. So acceleration is dv by dt, which is k into b, which is constant, and then differentiate e power minus bt. Again, chain rule. This is e power a function. So you should get used to this. So this is kb, and that will be minus b into e power minus bt. So acceleration is minus kb square e power minus bt. Sure. You want velocity at t is equal to 0. So at t is equal to 0, if you substitute, velocity will be k into b. E power 0 is 1. Check it out. Clear with this? Let's see one more. Any doubts on this? Others, keep your cams on. So the thing is, it is basic standard differentiation. The only thing I started calling it velocity and acceleration. So let's say velocity v is equal to root over t square plus t. V is velocity, t is time. V is equal to root over x square plus x. V is velocity, x is position. Find acceleration in both the cases. Basically chain rule. Both are chain rule, but yeah. 2 plus. Okay, let's see. I don't remember the answer. Even I have to differentiate. Try. I'll give you a minute for each. Be careful. They look same, but they're not same. This is what I taught you just now. If v is given in terms of t, use this. If v is given in terms of position, use this. So here acceleration के लिए you have to use v dv by dx. Here acceleration के लिए you'll use dv by dt. That is a difference in the question. So exam में they'll give you this, and most people will do this and get the answer, and that option will be there. So yeah, let's get this. Let's see the first one. So this is v is equal to t square plus t whole power half. Chain rule, everyone. This is looking like something to the power of half, isn't it? X power n जैसा लग रहा था. So this differentiation will be half into that function, which is t square plus t whole power half minus 1, and then differentiate whatever is inside. This will be 1 by 2 into root over t square plus t, and this will be 2t plus 1. There, that's your answer. 2t plus 1 by 2 into root over t square plus t. This much level of differentiation should be comfortable. This guy, first we will find dv by dx. So again, v is equal to x square plus x whole power half. So if I do dv by dx, we can see from here directly the answer will be 2x plus 1 by 2 into root over x square plus x. But this is not the answer. So this is a is v dv by dx. So v will be root over x square plus x, 2x plus 1 by 2 into root over x square plus x. So this guy and this guy will cancel. We get 2x plus 1 by 2. Is that clear, everyone? So what I have seen, right, in the exam, they'll ask this and they'll keep this option there, and most people will mark this income. People do silly mistakes, happens.
Sir,
Any doubt on this? Advai.
what is the exact difference between these two things?
You seriously can't see any difference between these two things?
Yes, sir. Time and position.
So the whole formula is different. You're late to the class.
Yes, sir. What was the meaning of R exactly here?
Position. R is position vector. Right? Here X is position, right? X is X coordinate. R is a position in 3-dimensional.
Hmm.
This is a simpler version of it.
Okay, sir.
Clear with that? X is position only, right? See, R means what? X, Y, Z. Here right now we are only doing with X. We are not bringing Y and Z right now. Okay? All clear with this? Got the differentiation? This much everyone is able to handle, right? Let's see one more. Now let's go a little higher. Let's make it more complex. Now differentiation, we really don't need more than this. So let's say R bar is T cubed by 3 I cap plus 1 by T J cap. There. Now I'm bringing vectors. So this is R bar, Rajay, what you're asking. So if I take only X, it is only X coordinate, isn't it? So this is X coordinate and this is Y coordinate. So T is time here. Find velocity as function of time. Find acceleration as function of time. Find the time when acceleration is perpendicular to velocity. Now, do you guys remember if two vectors are perpendicular, then what happens?
The dot product is 0.
Dot product is 0. There, vectors, calculus, combination. Let's get this. How to differentiate a vector? That was the last thing we did in the last class. So when you have to differentiate a vector, you simply differentiate the X component, Y component, J component, and then just put I J cap. So it's not really that different differentiation. It is the same thing. Yeah, find V of t, A of t, velocity as function of time, acceleration as function of time. And find the time when A and B are perpendicular. Yeah, get the time, get the time. Everyone got this? Anyone got the time? Ishman, what is that answer? -1 by +1. I don't understand what you typed. How can you get time negative, na God? Yeah. Right, Shreyan. Acceleration, let's see, velocity. dr by dt. So t cube ka differential is 3t square. 3 will cancel. T square I cap. 1 by t ka differential is t power -1. So -1 by t square j cap. Sure. T power -1 into t power -1 -1 1 minus t square. Acceleration will be differentiate this velocity dv by dt. T square ka differential is 2t I cap. Minus 1 by t square ka differential is t power minus 2. So that will be plus 2 by t cube j cap. If two vectors are perpendicular, then a bar dot v bar must be equal to 0. If you do the dot product, how do the dot product? Multiply I components, j components. That will be 2 into t square minus 2 by t cube into minus 1 by t square is equal to 0. You will get t cube minus 1 by t power 5 is equal to 0. T power 8 is equal to 1. So basically t is equal to 1 second. Clear with this? There, did you see? Differentiation, velocity, acceleration, kinematics, dot product, vectors. 3 different chapters. Any doubts on this? Srihari, clear with this? Ashvi? Clear? Anyone is confused, please ask Trishi, Utsa, got this? Siddesh? Shaunak? Shreyan? Clear. Next one. Let's say R bar cos 2t I cap plus sin 2t j cap. R bar is a position vector. Find angle between A bar and B bar. Let's get this thing. Find angle between A bar and B bar. Or let's do one thing. Find angle between A bar and R bar. That is better. So the moment someone asks you find the angle between two vectors, the best thing to do is dot product. That we learned in vectors. Nahi aa raha, that's not the answer. So differentiate 2 times, you'll get acceleration. Then do dot product. Nahi aa raha, that is also wrong. You got 2 minus 1 so far. Try. Take a minute, everyone, do it properly. Let's see whether you got the thing right. What is velocity? dr by dt. Cos 2t, it is cos of something. So that will be sin 2t and one minus will come outside. Cos ka differential, sin 2t. So minus 2 sin 2t I cap. Sin ka differential is cos, but 2t ka differential 2 will come out. 2 cos 2t j cap. Right, Ovia, you got it. Yeah, one answer, everyone. Samyak, that is wrong. Utsa, you're right. Everyone got this velocity? Now you differentiate this again. So acceleration is dv by dt. So every time you differentiate that sin and cos, 1, 2 will keep coming out. Sin ka differential is cos 2t, but 2t ka differential 2 will come out again. So it will become minus 4 cos 2t. Cos ka differential will be minus sin 2t. So 2 will come out again, minus 4 sin 2t. I hope everyone got this. Anyone is confused here, please ask me, I'll show you. Arya, you got -4 so far. Stop answering, Nari, you're getting everything wrong. Samyak, you got it. Any doubts on this part, please ask me. Once you got this, you want to find angle between two vectors. So a bar dot r bar is mod a bar mod r bar cos theta. This is the angle between the vectors. So let's do a bar dot r bar. So if you do a bar dot r bar, you have to multiply this and this and this and this. So that will be -4 cos square 2t -4 sine square. Just just a moment. Okay. Someone is just knocking the door. I don't know why. Okay, this is sine square 2t is equal to what is mod a bar? Magnitude of this vector, which is root over 4 cos 2t ka square plus 4 sin 2t ka square, and mod r bar, this magnitude, root over cos 2t ka square plus sin 2t ka square. Actually, you can see and tell here, both are anti-parallel vectors. This is the angle between them. Sin square plus cos square is 1 minus 4. That is 16, 16, that is also 4. This is 1 and this is cos theta. We get cos theta is equal to -1. Theta is 180 degrees. Clear with this? You could have done it much faster. Take out 4 common here. What will you get? You'll get r cap, no? So basically a bar and r bar are opposite to each other. If two vectors are opposite, what is the angle between them? 180. Can I write this thing like -4 r bar? So a bar and r bar are opposite. So what is the angle between them? 180. Are you clear with this? So luckily we got this thing directly, but every time it is not necessary. Have a look at this. So if you give me two vectors, this is how you find the angle. A bar dot r bar is mod a mod r bar cos theta. Everything is sine square plus cos square, so that becomes 1. All clear with this? Let's see one more like this. Any doubts? Anyone not convinced with this? Advai, clear with this? Ishpan? Ananya, got this? Shriyansh? Great. Arya, keep your cam on. So we have a circle of radius r. We have a particle here going with speed u. This is the scenario, t is equal to 0. This is your origin. This is your x-axis and this is your y-axis. So this particle is going along the circle. Particle goes in a circle with speed u. Find the position vector. Find r bar as function of time t. What is position vector? After some time, the particle will come here. So I want you to find this r bar. So once you get r bar, differentiate, find velocity as function of time t, find acceleration as function of time t. Get all of them. Start with the first one. And first one we have actually done before. In case you don't remember, do you guys remember this question? An ant is walking along the circumference with speed v. Find OA bar as function of time t. This was a position vector, isn't it? So this was done in vectors. So we are just repeating it again. Get it? This is what I was saying. We'll always keep going back. I just have only one chapter to connect back. If I have only 2 dots, I can join one line. But if I have 10 more dots, I can join multiple lines. So as more and more chapters come up, physics becomes more interesting. I still remember, I think your seniors,
Is any angle like theta given or
nothing is
isn't?
given. बस इतना ही दिया था. Radius or speed u. That is the actual whole question. You need to figure out that angle. I think last year, I guess, during revision, we made a question which had 7 different chapters. It was fun. Vanshika, got something? No, your brother is playing with the mic. I can understand. Younger brothers are evil sometimes. This is quite common. If you have an younger sibling, the sibling goes behind the screen and starts dancing in the middle of the class. She got disconnected only. This guy must be doing some nonsense. Yeah, just make them sit in the class now for 10 minutes. After listening to this physics, they'll run away after 5 minutes. Physics can be used as an anti-repellent to kids. Works really well. Anyone got the position? So you need to figure out the angle. Can you find the angle? That we have done before. That's what I'm saying. Revise the notes. You should know. So after time t, this particle will reach somewhere here. I need to find this angle. If I got this angle, my job's done. What is this length, everyone?
R theta.
Which is ut, na? R theta, nahi. Theta, you don't know. That is the distance, right? That is u into t. Agreed?
Yes, sir.
Speed into time will give you the distance. So what is theta? Arc length by radius, which is ut by r. Aa gaya na angle. So once I know the angle, I can just drop a perpendicular. This will be r. This guy will be r cos theta, and this guy will be r sin theta. I got the coordinates. Therefore, r bar will be r cos theta I cap plus r sin theta j cap. So take theta and substitute here. This will be r cos ut by r I cap plus r sin ut by r j cap. This is your position vector. You want velocity? Differentiate. You want acceleration? Double differentiate. Now can you try? I'll give you a minute. You'll get something interesting. You'll get something which you have seen before. This thing kind of looks like the previous question. It was sine 2t. Here it is cos ut by r. So remember, cos of something. So this entire ut by r is some function. So you have to differentiate ut by r again. I hope everyone is confident with the chain rule now. This much differentiation you can handle, meaning is sufficient for physics. Yeah, I think most of you got it. Get the acceleration also. That's it. So if you differentiate this, I'll write the answer directly, but in case someone needs help, ask me, I'll show you. So cos ka differential is sine. So minus sign will come, differentiate ut by r, u by r will come out. R will cancel, you will get minus u. Sine ut by r. Exam you should be doing like this. This will be sine ka differential is cos. So cos ut by r j cap. Anyone not clear with this, please ask, I'll show you.
So,
Clear na everyone? हाँ यशवी देखो ना cos का differential क्या था minus sign then this is some function na ut by r. What is ut by r का differential? U by r.
Yeah.
So that r and this r will cancel. So you'll be left with a u and a minus sign, isn't it? Cos will become sine and that will become minus u.
thank you.
Everyone else clear with this? Advai? Clear?
Yes, sir.
Clear na? Then what about acceleration? Same story. Differentiate velocity again. Sine ka differential is cos plus cos and ut by r when we differentiate u by r will come out. So this will become minus u square by r cos ut by r I cap. Cos ka differential is minus sine, so this will be minus u square. So every time you differentiate, one u by r will keep coming out. Sine ut by r j cap. Now, if you notice something here, this acceleration, if you take out minus u square by r common, this will become simply cos ut by r I cap plus sine ut by r j cap. This is nothing but acceleration is equal to minus u square by r into r cap. Does anyone know what is this? This is called centripetal acceleration. Did you study in school? How, Abhya?
Like what would be like u square by r square?
Nee, na. Where will you get r square? Sine ut by r is cos ut by r, and then when you differentiate ut by r, only one u by r will come out.
No, I was talking about the acceleration where you put r cap. I thought it was r vector.
Nee, na. See, na. I wrote r cap, I didn't write r bar. This is the direction of the vector, na. Dekho, this magnitude is only one. Okay, you want to write like that? Chalo, multiply and divide by r. You'll get minus u square by r square into r bar. What is r bar by r? R cap, right? Doesn't make sense. I can give one r to here. What is r bar by r? R cap. If you divide a vector by its magnitude, we get a unit vector. Is this clear, everyone?
Sir,
Huh.
so can we say that the acceleration for any circular motion is always towards the center?
Not necessary. If speed is constant,
Okay, sir.
and if speed is changing, it is not true. Then आपको ये u भी differentiate करना पड़ेगा ना. It will become a chain rule, product rule. Are you getting this? Did you study this in school? If a particle is going in a circle with speed u, meaning if you have not studied, then it is fine. It will experience an acceleration called centripetal acceleration, centrifugal force. Did you guys hear any terms like this before? Hi, Ishman, you heard about it. So that is the thing. So this u square by r is a centripetal acceleration. So this is how we prove it actually. But anyways, we will see this in circular motion again. But is this clear, everyone?
Sir, I have a doubt.
Bolo na.
How did S is equals to UT? How did it came?
S is equal to ut.
Yes, sir.
Speed is constant, na? What is
Yes.
distance travel? Distance is speed into time.
Understood, sir.
So since the particle is going with constant speed in time t traveled ut. So yeah.
Thank you, sir.
How did differentiate velocity vector? See na. What is sine ka differential, right, Aditi? Cos.
Yeah.
Cos aa gaya, but then you have to differentiate whatever is inside. What is ut by r ka differential? U by r into dt by dt, right?
Yes, sir.
So u by r comes out, na? So u into u by r is u square by r.
Okay.
Got it?
Yep.
Please check out this thing. I skipped a lot of steps. So try to do it. If in case you didn't get that, ask me, but get it cleared. Now, how will they ask a question in advance? So before that, let me teach you a concept and then we can jump ahead. Or let me ask you a question and then teach you the concept. So let's say we have a unit vector. Let's say we have a vector mod r bar is equal to 1. Basically, it's a unit vector. Find mod of dr by dt. So differentiate the vector. Differentiate the vector again. Then add it to the first differential. Differentiate the vector again. Third differential. So on. Do it 13 times. And then add them. This is how they'll ask a question. So basically, this is your 13th differential. So you take a vector and differentiate it 13 times and add all of them and get a magnitude of this. And this is your second differential. And so on. How do you even start this? So in order to start this, you need to know a certain concept. So let me teach you that, and then I'll get back to this question again. So question will be like this. What happens if you differentiate a unit vector? So listen, so let's say it is given mod a bar is equal to 1. If mod a bar is equal to 1, that means a bar dot a bar is equal to 1. Agreed? What is a bar dot a bar? Mod a cos 0, parallel vectors. So a bar dot a bar is 1. Differentiate on both sides. So differentiate on both sides. Remember, left hand side, there are two functions. You have to use product rule. So a bar dot dA by dt. So actually, when you differentiate now, you can do the dot product also directly here. And this will be dA bar by dt dot a bar. On the right hand side, it is 0 because it is a constant. So this will be 2 times a bar dot dA by dt is 0. So we got a bar dot dA by dt is 0. What is the meaning of this? If the dot product of two vectors is 0, then that means the vectors are perpendicular. So this implies the vector a bar, and if you differentiate the vector dA by dt, the whatever vector you get after differentiating are always perpendicular. Remember, this is valid only because it's a unit vector in this case, are perpendicular to each other. There, we proved something really interesting. So every time you differentiate a vector, it becomes perpendicular. This is completely a mathematical proof. You just differentiated and proved it. But there's a way to think why this happens. But have a look at this page once. There we are combining dot product vectors with differentiation. Yeah. Let's see in another way. Why? How can we prove this thing? Let's take a geometrical interpretation. Tell me one thing. How can you change a vector? If you want to change a vector, what can you change? You can change the magnitude, you can change the direction. Agreed? So if you have a vector a bar, so I can change this vector in two ways. One, I can change the magnitude, so delta a parallel, or I can change the direction, delta a perpendicular. So delta a parallel, this is responsible for increasing the length of the vector. The perpendicular component is responsible for changing direction. So when you say I have a vector with constant magnitude, and if you're saying it is changing, Tell me one thing. Let's say there is a pole here and you're standing at a certain distance from the pole. If the distance between you and the pole is fixed, and I'm telling you you're moving, how is it possible? The distance between you and the pole is not changing, but you're moving. How is that possible? Only if you go in a circle, isn't it?
Yes.
Is that making sense? If the distance between you and the pole is fixed, the only way you can move is if you go in a circle. And if you're going in a circle, every time if you see this vector and your velocity are always perpendicular. So here, since the vector, so a vector can change by changing magnitude or direction. Or both. But in our question here, magnitude is constant. That means the only way you can change is delta A perpendicular. Since the vector ka magnitude is constant, therefore only direction changes. So this is how you can prove the same thing. So delta A bar is perpendicular to A bar. These two are perpendicular to each other. Is this making sense? So
Sir,
you can prove this completely mathematically, or this is proving it geometrically. Arya.
sir, so for answer for the 17th one will be 1, right?
Let's see. Yeah. Is this clear, everyone? So let me put this in a more usable form, okay? So that means if I take a vector, listen to this thing. This is the more usable thing. So, and if you say this is your vector A initial, when this thing guys goes in a circle, again, it is going in a very small distances. This is A final. So this thing here is your change in vector. And this is perpendicular. Remember, this is valid only when A bar is constant. So this is how you can write. If mod A is constant, need not be 1, it can be any constant, but should be constant. When mod A bar is constant, then when differentiated, when a vector of constant magnitude is differentiated, it rotates by 90 degrees. It rotates by pi by 2 anti-clockwise. That means if this is A bar, if you differentiate this will become dA bar by dt. So this thing has rotated 90 degrees anti-clockwise.
Sir,
Hmm.
can you explain the geometric interpretation again?
This is the interpretation, right? See, you can change the vector here. Same thing, I'm saying vector of, if the magnitude is constant, then this delta A bar is always 0, right?
Yes, sir.
Then that means only this guy is left out, and this guy is always perpendicular to A bar.
Yeah. Sir, and can you
You
also
can,
explain why the magnitude will be constant for the differentiation?
no, see now, if you say this length of the vector is constant, now see, you're telling me this magnitude is constant, and you're saying it is changing. You tell me, how can you change this vector without, you can either change the magnitude or you can change the direction. But it is given in the question, magnitude of the vector is constant. Isn't it?
Yes, sir. Sir, but how can we say that differentiation is having the same magnitude? Like the rate of or the slope is having the same.
No, not like that. See now.
So from this we can say
Think
that
of like
the
this thing, same.
differentiation of a vector with constant magnitude is
So
constant.
देखो
That
ना,
same
if you
thing.
move this perpendicularly, this will never change the magnitude, right?
Yes,
The
sir.
perpendicular, one thing is changing your direction, one thing is changing your magnitude,
Yeah.
right? So when I differentiate this vector, so when you just try to see in terms of that, how do I put it? Simply think of like this. When you say a vector is constant magnitude, you simply fix this length, isn't it?
Yes, sir.
So when you say dA bar, you're saying I'm changing the vector. So that means after rotating this, means only your basically this arrow you're rotating front and back. You can't do anything else. So when you rotate it left and right, the only thing that you can change is the direction, isn't it? It'll always go in a circle.
Yeah. Got it.
And if you're going in a circle, this velocity will be always tangential, right?
Yeah.
So think
So
of like
it will
that.
be
I know you're
perpendicular.
trying to think in terms of an equation, na? Slope and all. Don't think in terms of slope. Slope is dy by dx, na? You're comparing y with x coordinate, then it is called slope. It's not called slope anymore. Got it?
Yes, sir.
So Aditi, listen to this thing. So if you differentiate a vector, every time you differentiate a vector, it rotates by 90 degrees. So let's say if a bar is this way, x-axis. If you rotate it once, dA by dt becomes perpendicular. If you differentiate this again, d square a by dt square. So this vector will again rotate 90 degrees. You're getting how it is? If you rotate, differentiate again, d cube a by dt square, this will again rotate 90 degrees. If you differentiate again, you'll come back to the same place. So this guy also becomes d power 4 a dt square.
But sir, after differentiation, why is it like rotating by 90 degrees only? Like, why is that?
Yeah, we proved it.
Oh, yeah,
If you differentiate a vector, it is always perpendicular.
it's always perpendicular. Okay, yeah.
I think, Arya, I got what you're trying to ask. Arya, listen. What I said now, I got what you're trying to ask. If a bar is 1, then the magnitude will always remain constant. But if the a bar has some value, then the length also will keep increasing, but the direction will always rotate 90 degrees.
Yeah,
Is
sir.
that what you're trying to
That was
Ah.
my question. Like
Yeah,
in
yeah,
the
yeah.
last question, in that circular motion question,
It will always
the
increase by
magnitude
R. I
was
got it.
increasing by folds, right? 4, 8,
Yeah,
like that.
yeah. I understood what you're saying. So only for a is equal to 1, it will remain constant. Clear with this? So if you keep rotating this, so one of the best example is that what we did right now, see. So when the particle was going on a circle, this was the position vector, agreed? If you differentiate this, what did you get? You got velocity. That was this dr by dt. If you differentiate this, what did you get? You got acceleration, which was this opposite to r bar, which was d square r by dt square. Did you notice this? Every time you differentiated, it rotated by 90 degrees. Didn't we prove this? A bar and r bar are opposite 180 degrees. So there, this result is important, everyone. Every time you differentiate a vector, this is what will happen. Clear with this? Now, can you solve this question? Now, how will you solve this thing? I'll help you with one. You guys do the next one. Now see, if I take dr by dt, now see for simplicity, right, I will take it as r1. We'll write this every time. So d square r by dt square, I'll write it as r2. So this is r3. This is r4. What will happen to all these vectors? They'll cancel out, right? So if you take a set of 4 vectors, they'll always cancel out. Is that making sense, everyone?
Yes, sir.
So these 4 vectors will cancel out. Then we will take R5, that is the fifth differential. 6th differential, 7th differential, and 8th differential. These guys also will cancel out. R9, R10, R11, R12 also will cancel out. The only one who's left is R13. So this guy is 0, this guy is 0, this guy is 0. So this guy's magnitude is 1. So what is the answer for this one? Understood?
Yes.
So every time you differentiate, it becomes perpendicular. So set of 4 vectors will cancel out. Any doubts on this? Based on this, can you tell me the answer of this guy then? What if I give you like this? dr by dt d square r by dt square, so on d14r by dt square? dr by dt d square r by dt square, so on till d15 d14. d16r by dt16. Can you do this thing? Triple one. Such a big value to have. Remember, every time you differentiate, you're getting 4 vectors basically. 4 will cancel out. So 14 mein how many will be left out? Up to 12, everything will cancel. So you'll be left out with only 13 and 14. And remember, both are 1 and both are 1 and both are perpendicular to each other. What is the resultant? If 2 vectors are 1 and 1 perpendicular, resultant is √2. Sure. What about this guy? R13, R14, R15. 13 and 15 will cancel. You'll have only 1 left. 1. R13, R14, R15, and R16 all will cancel 0. If you go to 17 again, that will look like 13 only. So in this kind of questions, you can have only like these 3 possible answers. Either you can get 1, you can get 0, or you can get √2. But are you getting the meaning of this? If you differentiate a vector with a constant magnitude, it will rotate by 90 degrees anti-clockwise. Any doubts on this? Quite a good concept. This is the proof basically that 2 vectors are always perpendicular.
So this would be like an advanced level question at
Yeah,
R level, right?
advanced. Yeah. Sudiksha.
Shouldn't the first 6 vectors cancel each other out? Because if we check in 3D, there can be one vector going into the page and one outside.
No. See, if you take one vector, single vector, a single vector, when it rotates, it will always be in a plane, right?
Yes, sir.
If you take one vector and when you rotate it, it will always be in a plane. So it's still in 2D only.
So it cannot come outside the plane, like in
No, see, it's like this. If it comes out of the plane, then it will be in that circle only, right?
Yes.
See, for example, if this is the thing you're saying it will come out like this or like this or like this, right? See, if you say I'm going like this, then you'll continue to go in this plane only. If you say I'll come like this, then you'll continue to go in this plane only. You're getting it? So all these vectors will be in the same plane.
Yes, sir.
What you're saying now, I think you're thinking like this. You'll go like this and then you go like this. Aisa nahi hoga. You will keep rotating in the same direction, 90, 90, 90, 90. Make sense? That way. Take a small break, come back by 9:40. We'll continue from here.
Sir, sir, what will happen to this differentiation in 3D? What can we assume to the length? Like, what can we say about the length of the
There is no 3D,
direction?
Ray. R bar is a 3D vector only, na? I cap, J cap, K cap.
Sir, but like, what perpendicular directions can we take? Like for XY plane, there are 4 perpendicular directions.
Hmm.
So will there be 6 like a 3D plane?
No. It'll always make one vector only perpendicular to that plane. It depends on the quantities actually. So, for example, देखो now. This function only will look different now, right? You know how will this function look? It looks pretty weird actually.
Will it be a sphere?
It will be a sphere, but even on that sphere, it will just go in one particular circle.
So what will determine that then?
I need to know more data about that R bar exactly. We need more information. Let's not get into 3D now. Let them teach you in vectors. But for 2D, it is clear, right? 3D, it will become very complex, right? Don't worry about that. We don't need it. Clear with this? 2D part is clear. Yeah. 3D may also it will go there. I need to know more information about that R bar. You need to give me what is the exact function. ठीक है, take a break. Come back in 5 minutes. Yeah, let's start off. Next thing is maxima and minima. Remember, it is not maximum, it is not minimum. It's called maxima and minima. So what is this exactly? So maxima is the maximum value in a local region. You can simply call them peaks. Minimas are simply minimum values in a local region. Valleys. So for example, if I give a curve like this, now if you notice here, 1, 2, 3, these are peaks. Getting it? 1, 2, this thing, 4, 5, 6 are valleys. So 1, 2, 3 are maximas here. 4, 5, 6 are minimas here. Now, if you notice something, that's what I'm saying. Maxima is not maxima, minima is not minima. If you look at here, the value of minima 6, isn't it greater than maxima 1? If you see 6 ka value is actually more than 1 ka value, so it need not be there. So value of 0.5, 0.6, which is a minima, is greater than value of 0.1, which is a maxima. So generally in maths, maxima is not maxima, minima is not a minima. But luckily in physics, we will not deal with all that stuff. So at least in our portion, 11th and 12th physics, maxima and minima, we will take it as maximum and minimum for our thing there. Others, do keep your cams on. Yeah, it's a local maxima and a local minima. Then they'll call a global maxima and global minima, but we'll just leave it like that and not get into so much math. But for our 11th and 12th physics, maxima and minima are generally maximums and minimas. Maxima and minima need not be the maximum.
So the maxima and minima x coordinates now.
Yeah, in this case, we are talking about the heights basically.
Bhai, okay.
Need not be maximum and minimum. All right. Generally, we assume them to be maximum and minimum for our curriculum. So keep that in mind. For physics, we can treat them as maximum minimum. Functions will be given like that. Maximum, they will take care of it. They have something called global maxima, global minima, and all that stuff. We treat them as maximum and minimum. Great. So how do we find this thing? Now, why do we need this thing also? Because later on you'll see, physics is a study of different physical quantities. So don't you want to study something like this? What is the minimum work needed to move a block? For example, if I say there's a block on the ground, are we not interested to find what is the minimum force required to move the block? Right? Or if I throw a ball, what is the maximum height reached by the ball? If you see these kind of things, we keep popping up, right? Maximums and minimums in a lot of different things. So we need to know. Right. So for example, if I have to show you maximum minima, right, will come up everywhere. For example, if you take in current, we have a question like this thing, say. Someone has given you n batteries like this, and these batteries can be kept in series or parallel. So we have so many batteries like this. So the question is, how should I keep all these batteries such that you get maximum current in this resistor? So if you get a question like this, so we do everything and we do something called maximum minima there, minimize. And when you differentiate that function, we get a value like this. So this is just not at some place, huh? This is in current electricity. Right? If you go to thermodynamics, there's a question like this. So there's a particular process here and you want to find the maximum temperature. So you basically get a function, maximum temperature, you have to differentiate. So this maximum minima, right, will keep popping up in different chapters in different ways. So quite an important thing, good mathematical tool. And we will just stick to only 2D here. So don't worry about 3D parts. So let's see, first of all, how to look at a maximum. So today we will do this. Next class, we will do applications of this. That will be more interesting. And then I think, yeah, maximum will be the maximum minimum will be the last part. And then we will go ahead with integration after this. That will be the main one. Integration is the key. Anyways, so let's see. How do you find a maximum? Look at this thing. It's pretty analytical. You can figure it out. So what is a maximum? Maximum is simply the peak of this thing, right? So if you try to observe the slopes, look at the slope, how it is. This is the tangent. This is the tangent. And this is the tangent. This is the tangent, and this is the tangent. Did you notice something? What is happening to the slope? Here, the slope is positive. Here, it is less positive. Here, the slope is 0. Here, slope is negative. Here, slope is more negative. You can clearly see as you go from left to right, we observe as we go from left to right, the slope is decreasing. Is that making sense? If I draw a tangent here, can you see this angle is acute? If I draw a tangent here, this angle is less. Here, the angle is 0. Here, the angle is obtuse. Here, the angle is even more obtuse. So as you draw tangents on this curve, you will notice the slope is decreasing. That is your first observation. Second thing, the slope at the topmost point is 0. So basically, when you're counting numbers, think of like this. If the numbers are 3, 2, 1, 0, minus 1, minus 2, minus 3. Whenever you're counting numbers from positive to negative, you will touch 0 once, right? So whenever you take a turn, you'll always get a peak or a valley. So these are the two conditions here. And look at the change in slope here. The slope is always decreasing. So the change in slope, what is change? Final minus initial. Look at this. Final minus initial. Final is lesser than this, negative. 0 minus positive, negative. So the final minus initial is always negative here. Change in slope is negative. So for minima, there are two conditions. Condition 1, the slope has to be 0. That is the first differential, dv by dx. Condition 2, the slope must be decreasing. So rate of change of slope must be negative. But what is slope? dy by dx. That means the second differential must be negative. Anything that satisfies this condition is a maxima. Don't worry too much about the mathematical part, just try to understand what it means. I hope everyone is getting the slope ka part. When you go from left to right, you can see it is becoming more flattish and then becomes more negative. And the topmost point, the slope is 0. and the slope is decreasing. So change in slope must be negative, but slope itself is dv by dx, so double differential is negative. I'll show you how to use this, but yeah, these are the two conditions. You can write it down if you want, condition 1 and 2 for maxima.
Sir, could you explain condition 2 again?
Dekho na, this thing is big positive, right?
Yeah.
Then when you went forward, it becomes small positive. So change is what? Positive or negative?
Negative.
Like this is plus 10 and this is plus 5. What is the difference? 10 became 5. It became, change is what? Minus 5, no?
Yes.
Then this became 0. What is change? Minus 5.
Minus 5.
Then 0 became minus 5. What is change? Minus 5 minus 0 minus 5.
Yeah.
So the change in slope is always negative, right?
Yeah.
So what is d of slope? Change in slope, no? So change in slope is negative.
Okay.
So as you're traveling from left to right, you're observing slope is decreasing continuously. So change in slope is always negative. Is that statement making sense, everyone?
Yes, sir.
This is a condition for maxima. Second one, if you take a minima, this will be like a valley. Now look at the slope here. So at the bottommost point, if you see the slope is 0. So here, slope is negative. Here, slope is positive. So this is reverse. As you go from left to right, slope increases. Did you guys ever think about this way? When you're sending a robot or anything to Mars, or even if you have a robot in your house which is roaming around, how does this thing map the area? Let's say if you're sending a robot to Mars and you're telling it to map the entire surrounding area. How will the robot know that it has reached a valley or it has reached a peak? How will you program that in your coding? You're getting it. Let's say you have a rover. You told that rover, right? You launched it on the Mars. And the job of this thing is to map this entire area. You want to get the geography of that entire Mars. Now, one thing, you can take photographs and stuff. But let's say if you're teaching your robot how to walk. You're getting it. So how will you code that in the program that you have reached a hill or you reached a valley? Anyone? Bolo na Arya.
Sir, for a valley, we can see that the speed of the robot will start increasing as it goes down.
Now, how do you know that, right? Maybe robot, if you put more, meaning you meaning say, I can't create a motor which will accelerate you up the hill.
I mean, it will require more work to do, right?
नहीं, but जो coding में कैसा करोगे ना? How will you put that into the coding? It becomes very difficult to get that data. See, what do you guys think is coding? Coding matlab you'll sit in front of a computer and type the keys and coding is done. Coding is how will you use your logic to figure out, like, how will you write that thing?
So data points.
I mean, what data points? Why बोल रहे हो? क्या है data points? How will you measure that? Now, there are multiple ways to do it maybe. One thing I can think of is this. See, this is what I will do. So you will tell the robot, you know, if I go forward, you'll ask this thing, is y increasing or decreasing? If you go forward, y increased. So what to do? Continue going forward. Go forward, y increased? Yes. Go forward, y increased? No. Okay. So in this direction, this is the highest point. Now I'll say go to the left. If I go to the left, did the height increase? No. Then come back. Go to the right, did height increase? No. Come back. Go to the front, did height increase? No. Come back. That's the highest point, right? When you're standing at the highest point, if you go front, back, left, right, in every direction, the coordinates will decrease. The height will decrease. Is that making sense?
So,
Same thing, when you're in the valley, front, back, left, right, the coordinates will increase. You can measure the height, right, from the ground level. How much you went up and how much you went down. That even your watch does it, right? Did you guys ever do that? If you take your watch and walk stairs, it will even tell you how much height did you climb. So those kind of sensors we have. So you can get the data about that. But this will, so end of the day, when you tell your computer to draw all these things, right, it will draw something like this. So wherever it couldn't go up, so it will start plotting the entire 3D may, it will plot the entire geometry there. But this will take a lot of time. This thing has to literally walk each and every coordinate. So maybe one robot will not do the job. Maybe you have to release something like 100 or 200 drones. Then these things will just keep flying and keep covering the area. Maybe there's a more efficient way to write this algorithm. Sonar doesn't work, right? Sonar is, you know what? For example, see, if you have water there and if you have a submarine, enemy submarine sitting there, as long as the submarine is sitting there, your sonar will do nothing. You will think it is just a rock. Only when the submarine starts moving, then your sonar gets messed up, and then you know there is something moving there. So sonar really can't give you the depth. Did anyone ever had a sonography here? You are too small, you guys won't have it. When you go for a job application or something, right, they'll ask you to get a full medical checkup. So what they do, right, sonography, they will make you drink a lot of water first of all. You will drink a lot of water, almost 2 liters of water. Then they'll put a machine on your tummy and then they will start, you know, sending waves into your tummy and they get reflected. So in case you have any stones or any kind of, you know, issues with your tummy, right, those things will get deflected. That is how they scan the whole thing. At least you must have seen in movies, na? The baby is inside the womb. When you scan that, you can see the baby inside. So that is basically sonar. Anyways, that we will see later on. In sound waves, we will discuss a bit about it, but it's not that. So as we go from left to right, what happens? The slope increases. And if you see, the slope at minima is also 0. This is the reason why you need a condition 2. Because minima, maxima, both the places, the slope is 0. So for minima, condition 1, slope is 0, which is dy by dx. For condition 2, the slope is increasing. So dy dx of slope is positive. So the second differential must be greater than 0. Let me show you how to use this, but there. So slope is 0 and second differential is negative, is maxima. Second differential is positive, is minima. There, this is the mathematical part of it, but let's see how do we use this.
Sir, so what if it is a higher degree equation like 4 or 5? There will
I'll
be.
show you. We'll show you.
Okay, sir.
I'll copy
And
this.
will it have both maxima and minima?
Yeah, have patience. I'm not running away. I'm there. I'll be teaching you. Have patience. Still have something which is unresolved. You can see me end of the class. But all clear so far, everyone? Others do keep your cams on. So let's see a question. That will be the best way to learn. Mathematically, you got it, but let me show you with a question. Listen, I'll show you one problem, then I'll ask you one more like this. So let's say we have a function y is equal to x cubed by 3 minus 3x square by 2 plus 2x plus 1. So this function y is depending on x. Now we want to find what is the maximum value of y or minimum value of y. We don't know, it can be anything. Find maximum or minimum value of y.
So for
Okay.
maximum, the second differential must be negative.
Yeah.
Right? Okay.
For maximum, second differential must be negative. So look at how to solve. Step 1. Differentiate dy by dx. How much is this? X square minus 3x plus 2. Right? So this is the condition 1, right? So condition 1 says that the first differential is 0. dy by dx must be 0. So x square minus 3x plus 2 is equal to 0. So we get x is equal to 1 and 2. Now we have a problem. We don't know who is maximum and who is minimum. This is the reason why we need a second condition. Which one is maximum and which one is minimum, we are not sure. Step 2. Double differentiate. So d square y by dx square, this is nothing but d by dx of dy by x. So differential of this. This is d by dx of x square minus 3x plus 2. This is 2x minus 3. This is your double differential. Now condition 2. So at x is equal to 1, so we don't know who is bigger, right? X is equal to 1, d square y by dx square. You have to substitute here. This will be 2 into 1 minus 3, which is minus 1, which is negative. So if the second differential is negative, what it is? It's a
Maxima.
Maximum.
maximum. So matlab at x is equal to 1, you're getting a maximum value. If you put x is equal to 2,
Minimum.
d square by dx square is coming out to be 2 minus 3, which is plus 1 greater than 0. This is a minimum. So there, that is how we figured out which one is maximum and which one is minimum. Clear with this? Question is still not over. You just found out if you put x is equal to 1, you are getting a maximum. If you put x is equal to 2, you are getting a minimum. Have a look at the steps once. So a function can have both maxima and minima. It can have 10 maximas and 20 minimas also. 10 minimas also. So clear with this? So you will get y maxima when x is equal to 1. So substitute there. So what is the function? 1 cube by 3 minus 3 into 1 by 2 plus 2 into 1 plus 1. How much is this? 3 by 2 plus 1 by 3. This is 11 by 6. We don't know the line at end of the parabola is extend to infinity. What are you talking? Where is the parabola here? Arya?
Sir, no, I'm talking in general.
What is that general?
So like at the ends of the parabola, the equation extends to infinity.
What does that has to do with this?
Sir, I mean the maxima will be infinity. Can we say that?
There is no defined na maxima ka meaning is what? Peak, right? Is that a peak?
No.
Then
So I mean it
who
will
told you?
keep extending.
So it's not a peak value, na? So it's not a maxima.
Okay. So maxima and minima refer to where the function starts to decrease or increase again.
Maxima minimas are peaks and valleys. Na?
Okay,
That's it.
sir.
Simply, it is a peak and a value. Matlab, it should turn. That's it. If the function is going like this, there is no maxima, there is no minima. So this will be 2 cubed by 3. This is minus 3, 2 square by 2. 2 and 1. How much is this? Someone got it? 5 by 3. Which is bigger? 11 by 6 or 5 by 3?
11 by 6.
11 by 6 is bigger. So approximately, yeah, I'm not sure about the graph, but if I have to draw this, y versus x. So this graph must be looking something like this. If x is negative, if I put x is equal to 0, I'll get y is equal to 1. So graph starts somewhere here. This is not the exact graph, I'm just roughly drawing it. So x is equal to 1, you'll get a peak like this. X is equal to 2, you're getting a valley here, and the graph must be going off like this. The graph will look something like this. I'm not sure exactly how, but something like this. So you will get a peak here and you'll get a valley here. But you're getting the value on both the sides will go to plus infinity and minus infinity. Is that clear, everyone? I think if you can just go online and ask them to plot the graph now, the AI will show you the graph. But yeah, this much I can guess. There is a peak here and there's a valley here. Again, everyone got the steps? Differentiate equal to 0. If you get two roots, one root if you get, most of the time it is easy. But if you get two roots, then double differentiate, put the value, see which is negative, which is positive. That is maximum and minimum. Have a look at the steps. I'll give you one more like this. You guys try now. Yeah? हाँ बोलो ना भैया.
So why do we take maxima as like maximum minima and where like slope is 0?
Because see now, whenever you are having a turning point, the slope, the line always becomes flat, right? The tangents will make 0 slope.
But it's not the maximum value the function.
No, when did I say maximum? Maxima is never maximum. Isn't that something I wrote in the beginning? Maxima is not maxima. Minima is not minima.
I was confused, I guess.
Maxima, minima are never max. See, for example, this function ka maximum value is infinity, right? But in physics, right, generally the kind of equations you get are mostly parabolic. So physics mein. So most of the time maxima becomes maxima, minima becomes minima. In physics, 11th and 12th. That's it. So now you guys try this thing. So I'm asking you cubic, but normally you'll not find cubic equations in physics ka solving. 5x square by 2 plus 6x plus 1. There. Find maximum and minimum of this. Same thing, I just change the numbers. Get it. I'll give you 2 minutes. Like I said, this is a tool. The questions will not be asked like this. I'll show you how they'll ask questions also. — 17 by 3 and 11 by 2. Yep. Most of you got it. Try another 30 seconds. I'll show you then. Yeah, I think most of you got it.
So
So
what
step
if
one,
both
differentiate.
come out to be minima?
That will never happen. Think about it. You can, if you have a minima here, before going down again, you'll always get a peak.
Yeah.
So this thing, right, philosophically tells you like this. In your life, you can never be continuously happy. Or you can never be continuously sad. So if you're happy and next time when you want to be more happy, you have to go down a bit and then you'll go to the next happiness. Or same thing with the progress. You can never continuously progress. Every time you come down a bit and then you reach the next peak. So you'll never get two consecutive maximas or two consecutive minimas. So anyways, step one, if you differentiate this dy by dx, we get x square minus 5x plus 6 equal to 0. Then we get roots x is equal to 2 and 3. We don't know who is maximum and who is minima. So we do step 2, double differential. This is 2x minus 5. So x is equal to 2. The second differential is -1, which is less than 0. This is your maxima. At x is equal to 3. The second differential will be +1, which is greater than 0. This is your minima. So you get y maxima when you keep x is equal to 2. How much is this? 17/3. Y minima is when x is equal to 3, and this is 11/2. Check your answers. Is this clear, everyone? Oh, yeah.
Sir, like when x is 2, it will be minimum. No, okay.
It's less than 0, no? Yeah. All clear with this? Let me ask you one more function. But any doubts on this? Srihari, Trishi, clear with this? Utsa? Vanshika? Ashvi? Clear? Ananya? Pratyasha? Shaunak? Shreyansh? Perfect. Similar one. Let's say y is equal to x plus 1/x. Find y maximum and y minimum. And can you plot the graph? Try to plot yx graph. You will see something interesting here. If you have to draw this graph, how will the graph look like? If you plot the graph, you'll see something interesting. Naresh, man, that is when you get maxima and minima. Are you got the values. If you plot the graph, you'll see something nice. Ishman, you found x ka value, na? Maximum minimum of y is you have to put x ka thing back again. Try. 1 more minute. Right, Arya, I said, na? You got the values. I said, plot the graph.
It will not be possible for 0, right?
What do you mean by that?
Sir, 1/0 makes no sense.
That is infinity, na? My value goes off to infinite. I'll show you how the graph looks. Okay, let's see how to solve. Step 1, differentiate. That will be 1 minus 1 by x square. Equate to 0, you'll get x is equal to plus or minus 1. So there are 2 roots. Step 2, differentiate this again. This will be 0. This will be minus 2 by x cube. So 2 by x cube. At x is equal to minus 1. Double differential is negative. This is your maximum. At x is equal to plus 1. This is your minima. So at x is equal to minus 1, you are supposed to get y maxima. This will be minus 2. At x is equal to plus 1, you're supposed to get minima. The value is plus 2. Did you notice something? Minima is bigger than maxima. That's what I said. Maxima is not a maximum. Minima is not a minimum. Maxima, minima are simply the turning points. So how does this graph look like? Listen to this thing, how to draw the graph. So the function is y is equal to x plus 1 by x. If I put x is equal to 0, you'll get 1 by 0, that is infinity. The graph goes something of this sort. So at this point, which is x is equal to 1, you will get y is equal to 2. This is a minima. Look at the graph. If you put x infinity, y is infinity. If you put x0, it is infinity. You're getting it? That is how the graph looks. Should have roughly an idea how the graph looks. Similarly, if you put y negative, the graph looks like this. This is x is equal to -1 and y is equal to -2. This point is your maxima, the peak. It is difficult to guess the turning point, but yeah. You're getting this? So there is a maxima, there is a minima, but these are not maximum and these are not minimum. But remember this, physics may not encounter this kind of stuff. I'm just showing you one to get an idea. Max may have a full chapter on this, they will handle this. But got the idea here. This is how the graph looks. Now let's see some applications, how they will ask in physics. Let's do one or two, then we will do more in the next class. All clear with this? Everyone got the process right? Differentiate, equate to 0, you'll get 1 or 2 roots. Put them in the second differential, check whether it is positive or negative. Let's see a question. In an orchard, so listen carefully. There are 50 apple trees. Each tree produces 800 apples per year. Big trees. Now what happened? You became a little greedy and you said, "Yeah, itna apples are hai, so let me plant more trees." But the problem is when you put more trees in a given area, they start fighting for resources. So for every new apple tree that you plant, the production of each tree decreases by 10. Is this making sense? So production of each tree decreases by 10 apples. And instead of producing 800, they'll produce 790 now. Meaning, just to give an example, 50 trees, if you plant one more tree, now what will happen? You'll have 51 trees and you'll produce 790 apples. Are you getting it? You're still making profit, right? So the question is now, the thing is, how many more trees can you plant? But if you plant too many trees, all the trees will die and you'll get 0. So there is a limit. So how many more trees can be planted to maximize production? The biggest headache in calculus and physics is not the equations, but converting an entire verbal statement into an equation. This is a simple way of asking. Is the question understood? I have 50 trees in an orchard. Each tree will produce 800 apples. For every tree that you plant, all the trees will start producing 10 apples less. For example, see, if you plant one tree, all the trees will produce 10 apples less. So you lose 500 apples, but this one new tree will produce 790 apples. Still, you're making a profit of 290 apples, isn't it? So there's a limit. Let's say you get too greedy and you planted 80 trees. Then all the trees will produce 0 apples. All the trees died. So there's a limit. How do you solve this using calculus? This is a maximum minimum problem. So how do you convert these verbal statements into an equation? Think, I'll give you 1 or 2 minutes.
So can the trees be removed?
Nah, to be na. And if you remove the trees, you'll not get more apples, na record. Or you're saying if I remove the trees will produce more apples. Aisa concept nahi hai. Trees are not greedy like humans. They will take only whatever is necessary. 40. Hey, 40 is too much. Deforestation, it seems. Yeah, you got it. Ishman, you got it. You have two answers. Listen how to make this into a statement. Let the new trees be X. Okay. Let the production of apples be B. So I'm making variables here. So what is the production P? P is the total number of trees into apples per tree. So if you have planted X trees, how many trees are there? Initially you have 50 plus X. So you have 50 plus X trees. And what is the production? Initially each tree was producing 800. For every one tree, you lose 10 apples. If you plant X trees, you lose 10X apples. Is that making sense, Harry? If you plant one tree, it is 800 minus 10. If you plant two trees, it is 800 minus 10 into 2. If you plant 5 trees, 10 into 5. If you plant X trees, it is 10 into X. Is that make sense? So we got an equation. So the production will be, multiply this, it will be 40,000 plus 800X minus 500X plus minus 10X square. We got a quadratic equation. So P is equal to 40,000 plus 300X minus 10X square. Now question has simply become, find the maximum value of this function, isn't it? Isn't this the question? Find the value of X so that P is maximum. So we want to maximize this. So for maximum, what we do? First differential, dP by dx. 0, 300 minus 20x is equal to 0. We get x is equal to 15. You want, you can check the second differential also. But yeah, since they're asking maximum and there's only one value, it is 15 only. Done. And what is the maximum production? So put x is equal to 15. You will get 65 into 650. So 42,250 apples. There you can increase the production by 2,250 apples. If you try to do this graphically, let me show you the graph. So if I plot this graph, P versus X, it's a parabolic graph you will learn in maths. The graph would look something like this. So when X is 0, you are getting 40,000 apples. As you plant more and more trees, the production will increase and then will go off like this. So this peak value will occur when X is equal to 15. And all the trees will die when you reach somewhere here. So this value is 42,250. Isn't that the maxima, the turning point? You're getting how is the question framed? So the problem is not differentiation. Did you realize something? Differentiation was easy, right? The headache is how will you convert this entire statement into this equation? This is always the headache in physics, converting the form into an equation. Once you got that, it is easy to solve. Clear with this, everyone? This is how applications will be. So we will see more of this thing in the next class. So next class will be physics with calculus applications. So till now, what we did is almost math only. This is literally math, chapters only max. So next class when we catch up, we will do more of maxima, minima, and we will do some rate of change and all that stuff. Mostly next class we should finish off differentiation, and then next week we'll start off with the integration. Okay, with that we'll wrap up for the day. So if you have any doubts in the class notes, if you have any doubts in the sheets or anything, you can ask me, or else you're free to leave. So we'll again catch up on Thursday as usual at the same time. So First, we will see any doubts in the class notes, then we will see any doubts in the sheet, and then I'll